Exercise 2.5 9 sum. So here matrix A is given, matrix B is given, and find matrix X such that XA is equal to B. So here matrix A is given, matrix B is given. You have to find matrix X. So first we'll write and take XA is equal to B. See, this A is this side, so this side, so we will here we have to do column transformation. If A is this side, then you have to do row transformation. So this X as it is, write and take matrix A, matrix B. Now by column transformation, this you have to make the identity matrix. When you make this an identity matrix, it will become Xi is equal to this matrix. Means to the left hand side and right hand side we have to make the same transformation. So this matrix you have to convert into identity matrix. So here see by columns, so this by column transformation. So this say this you have to make 1, and this 3, and this 3 you have to make it 0. Now first for column transformation we'll start from here. This first we have to make it 0. So how to make it 0? Suppose this minus this we do, then it will become 0. Means C3 minus C1 if you do, we can easily it becomes 0. So first transformation is C3 changes to C3 minus C1. So C1 C2 write down as it is. Here also C1 C2 write down as it is. So it will be easy for you. Then C3 minus C1. So 1 minus 1 0, 3 minus 0 3, and 1 minus 1 0. And here also same, 3 minus 1 2, 5 minus 1 4, and 7 minus 2 5. Now this 2 is there, that we will convert into 1, because identity matrix means this 3 we have to make it 1. So this here 3 is there, here 2 is there. So how to make it 1? So C2 changes to 2C2 minus C3. See here 2C2 means when it becomes 4, 4 minus 3 will be 1. So this transformation make to both the sides. So this X as it is, then C1 C3 as it is, C1 C3 as it is, and C2 changes to 2C2 minus C3. So this will remain, here 0 is there, this will remain 0. Then 2 2s are 4 minus 3 1, and 2 2s are 4 minus 0 0. So this has become 1. Now here also C1 and C3 write down as it is. Now here C2 2C2 minus 3 C3 means 4 minus 2 2 2 into 1 2 minus 4 minus 2, and 4 2s are 8 8 minus 5 is 3. So both side we have done the same transformation. Next this 3 convert into 0. Next step is, first this we have converted it to 0, this we have to convert it to 1, then this we have to convert into 0. So here we have converted into 1, so it becomes easy to convert this 3 into 0. See, when 1 is there, easily it can be converted, this column we can convert into 0. So transformation is C3 changes to C3 minus 3C2. Means when you multiply here by 3, it will become 3 minus 3 is equal to 0. So C3 changes to C3 minus 3C2. Therefore write down C1 C2 as it is, and this remains 0 only. This becomes 0, C3 minus 3C2, and here see C3 means 0 minus 3 into C2. So 4 3s are 12, and this minus sign, so it has become minus 12. And this here also same transformation you have to carry out. First two columns write as it is, and C3 minus 3 C2. C3 is 2 minus 3 into 2 is minus 4. Then 4 minus 3 into 2 10, and 5 minus 3 into 2, that is minus 4. Now this has become 0. Now this we have to convert into 1. So without changing anything other, this we will convert into 1. So if you multiply this by minus 12, this will be converted into 1. So see the next transformation. C3 changes to C3 upon minus 12. So C1 and C2 write down as it is. Now C3 divided by minus 12. So this will remain 0, 0 only, and this minus 12 upon minus 12 is 1. Here also C1, C2 write as it is, and here minus 4 divided by minus 12, 1 upon 3. 10 divided by minus 12, minus 5 upon 6, and minus 4 divided by minus 12 is 1 upon 3. Now this we have converted. See, the diagonal elements have become 1. Now we will convert this 1 into 0 first, and then this into 0. Then our matrix will be, identity matrix will be completed. So how to convert this 1 into 0? Then suppose 1 minus 1 you do, it becomes 0. So here 1 is there, no change will be there. So say C1 changes to C1 minus C3. So this and this C2, C3 write down as it is both the sides, and say 1 minus 0, 0, 0 minus 0, 0, and 1 minus 1, 0. This 2 as it is. Now here also these two columns write as it is, and 1 minus 1 by 3 is 2 by 3, 1 minus minus plus 5 by 6 is 11 by 6, and 2 minus 1 by 3 is 5 by 3. Then now this 4 we have to convert into 0. So now here see 1, this 4 you have to convert into 0. So here 1 is there. So if you multiply this by 4 and this minus, if you minus this both, you will get 0. So when 1 is there, then it will be easy to convert the element into 0. So transformation will be, we have to change the C2. So C2 changes to C2 minus 4C3. So now first column as it is, third column as it is. So here no change will be there, and this will become 4. C2 means 4 minus 4 into 1 is 0. Same transformation here you have to carry out. First and third column as it is. Now C2 means 2 minus 4, 2 minus 4 upon 3, 2 upon 3 minus 2, this minus minus will become plus 12 upon 6, 4 upon 3, and 3 minus 4 upon 3 is 5 upon 3. Now this has become the identity matrix. So you can write it here, I. X into I is equal to this matrix, converted matrix. So X is equal to this answer. So when A and B is given, we got the matrix X. Now see 10th sum. 10th sum is same, only what is given here, AX is equal to B is given. There it was given XA is equal to B. Same here also you have to find the value of X. Only what change is there, here AX is equal to B is there, and there XA is equal to B is there. Now here AX is equal to B is there, so here you have to use the row transformation. There we used column transformation. Now when AX is equal to B, use row transformation. A we know, X and B also we know. So now this you have to convert into identity matrix, but by using the row transformation. Now for row transformation, this first you have to convert into 1, which is already there. Now this you have to convert into 0. So how to convert this into 0? If you do R2 plus R1, this will become 0. So R2 changes to R2 plus R1. So minus 1 plus 1, it will be, first write down first and third row as it is. Here also 1 and 3 as it is. And see now here it becomes 0, and R2 plus R1 means 1 plus 2, 3. 2 plus 3, 5. And here 2 plus 1, 3. Now this 1 we will convert into 0. After converting this into 0, next step is convert this 1 into 0. So how we will convert into 0? See, if you minus R3 and R1, we will get here 0. So first write down first and second row as it is, here also first and second row as it is, and carry out the transformation. R3 minus R1, that is 1 minus 1, 0, 2 minus 2, 0, 4 minus 3, 1, and here 3 minus 1, 2. Next one, now this 3 we will convert into 1. So this diagonal elements will become 1. So how to, without changing other all elements, how to convert this 3 into 1? Divided by 3. So R2 changes to R2 upon 3. So first write down R1 and R3 as it is, here also and here also. Then this we have to convert into 3. So divide by 3. So it will remain 0, here 1, and here 5 by 3. And here 3 divided by 3 is 1. Now this 3 we have to convert into 0. First down we have converted, now this 3 we have to convert into 0. So first we will convert this 2 into 0. So what you will do? Now see here, here 1 is there, so easily we can convert. If you multiply this by 2, 2 minus 2 will be 0. So R1 changes to R1 minus 2 R2. So R2 and R3, right here also and here also, write as it is, and this R1 minus 2 R2. So R1 minus 2 R2, it will become 0. This as it is 1, and here R1, that is 3, minus 10 upon 3 is minus 1 upon 3. And here also see R1 means 1 minus 2 into 1, that is minus 1, and this 2 as it is. Now next step, see, next step we will convert this into 0, minus 1 by 3 into 0. So how to convert that minus 1 by 3 into 0? So R1, this you have to convert into 0. So R1 changes to R1 plus 1 upon 3 R3. Okay, if you R3 here 1 is there, if you multiply, here minus 1 upon 3 is there, here if you if it becomes 1 upon 3, this plus minus 1 upon 3 and plus 1 upon 3 will become 0. So R2 and R3 write as it is, and this and this will remain same, and R1 plus 1 upon 3 R1, this will become 0. Here also same transformation you have to do. Now this 5 upon 3 we have to convert into 0. So there also same transformation we will use with R3. Suppose if you, here it becomes 5 upon 3, then if you multiply this by 5 upon 3, then 5 minus 3 minus 5 upon 3 minus 5 upon 3, it will become 0. So do transformation on R2. So write R1 and R3 as it is, here also R1 and R3 as it is, and R2 minus 5 upon 3 R1. So here it will become 0, and here it will become minus 7 by 3. So this has become identity matrix. So I into x is equal to this matrix. So I into x means x is equal to minus 1 upon 3 minus 7 upon 3 and